This is Programme 5 of VideoTel's series on practical marine electrical knowledge. The series is made up of 8 programmes. Programme 5 deals with the lighting circuits, the navigation light circuits, the steering gear pump motor feed circuits, the galley equipment and other ancillary circuitry, such as the general and fire alarms, other alarms connected with unattended machinery space operation, UMS, and the ship's cathodic hull protection. We end with emergency batteries. There are many system variations around, so it's most important that you become familiar with the components of the electrical system and the layout of the main switchboard immediately you join a ship. Pay particular attention to the layout of the emergency switchboard. This study will pay dividends during a blackout or when troubleshooting the cause of a major breakdown. Now we must emphasize electrical safety. The golden rule is, before any work is done on an electrical installation, first isolate the circuit by removing the supply fuses or locking the circuit breaker in the open position, so that the circuit cannot be energized accidentally. Then post a warning sign to alert others that the circuit is being worked on. Then prove the circuit dead with a voltmeter or an approved line tester. A switchboard can never be considered dead unless all AC generators connected to it are stopped, locked off, and all other supplies are disconnected. These points can never be emphasized strongly enough. The electrical rescue procedure is described in Programme 1 of this series. We begin with the lighting system on board ship.
The lighting circuit on board ship is usually 220-volt or 110-volt AC supply, provided by a set of step-down transformers connected in delta-delta. On the rare occasion when one of the 3 single-phase transformer units may develop a fault, it can be disconnected by first removing these primary fuses, then removing the secondary links of the phase affected. The transformers will still provide the voltage of 220 or 110, as the case may be, but at a reduced power, at about 60% of rated output. This state is called the open delta connection. The supply voltage in a single-phase circuit on board ship with an insulated neutral electrical system is measured not between a line and a neutral, as on shore side, but between 2 lines. All the miniature circuit breakers or fuses in the system, therefore, interrupt both live lines in a low voltage circuit. Also, double pole switches must be used to isolate feeder circuits from the live lines.
Never replace a double pole switch by a single pole switch in such a circuit. Whatever task you may undertake on board a ship, you will need light when you carry it out. Because of the varied illumination levels needed, a number of different light sources are used.
Fluorescent or incandescent lamps are used in a variety of fittings. Note the red disc next to some of them. These are fed from the emergency switchboard or batteries. For illuminating larger areas, mercury or sodium lamps are used in a number of different fittings. No lamp should be changed while power is connected to them. This is especially true in the case of sodium lamps. They work with very high voltages. Also, when you're changing quartz iodine lamps, do not touch the quartz envelope of the lamp with your fingers, as this will shorten the lamp's life and lower its efficiency. There is a whole range of fittings, weatherproof, explosion-proof, or both, which are used in hazardous areas, some of which are seen here. The essential thing to remember is that the flanges of the weatherproof fittings normally hold a weatherproof gasket between them. But the explosion or flame-proof fittings must have a flame path clear between the flanges without gaskets or paint obstructing it. Some lighting applications provide very large areas with a prescribed light level. 50 lux for instance, for safe cargo working at night on deck areas. The maintenance of the fluorescent lighting involves the replacement of the tubes, checking and replacing the starter unit, and occasionally checking the choke unit for burnout or open circuit. The cathodes of a suspect tube can be checked for low ohm continuity with a multimeter. The same applies to incandescent lamp filaments. After the tube is replaced, clean the diffuser before refitting it. Servicing hazardous light fittings with special flanges, seals, screws, nuts and glass covers is a more exacting job and is described in detail in Program 6. There are also light fittings which include their own battery power supply and provide emergency lighting for a period of about 3 hours when generated power fails. The model seen here has its own battery charger system built in. This will keep the batteries in fully charged condition. All external weatherproof lighting fittings must be cleaned and their flexible cable connections checked periodically.
This brings us to some special light circuits, the navigation lights and the not under command or NUC lights.
A number of different types of navigation light panels exist, but they will normally have a mains changeover switch and other switches for connecting a single light in each pair of lights at each position to the supply. This drawing shows the required feed circuits for the navigation lights, coming from 2 different distribution boards. One fed from the main switchboard, the other from the emergency switchboard. If the alarm indicates a fault on the system, first check the lamp for the circuit. If the lamp is healthy, check the fuses, the module boxes, and the relays. Periodically test the not under command lights on the main mast. Both the mains and the emergency supplies must be fully operational.
Among the most important circuits on board ship are those which feed the steering gear motors. In fact, 2 independent circuits are provided, usually one from the main switchboard and one from the emergency switchboard, or from each side of the main switchboard.
The 2 circuits run separately to the steering flat, one on the port side and one on the starboard side. Both steering gear supplies can be switched to either motor via a changeover switch, and both motors have stop-start facilities at the steering flat and in the wheelhouse. Also in the wheelhouse, the steering gear monitoring alarm system will give audible and visible alarm signals in case of steering gear motor failure or overload condition. The overcurrent relay does not trip the starter of the steering gear motor, but activates an alarm.
All these circuits use thousands of meters of cable of different sizes and design.
If a cable becomes damaged and is replaced, always use a cable of the same specification as that of the original. The ship's drawings will have the specification for all cable sizes. Lay the cable neatly in an appropriate cable tray, clipped to ensure safe and secure hold for the cable. Cables for the intrinsically safe circuits must be run separately and clearly marked for identification. Here, color coding has been used. Also, these cables should cross power cables at right angles, and the screen should be earthed at the supply end only.
Now, some may argue that the wettest and greasiest place on board ship is the galley. Working with electrical equipment there needs extra care for safety. The electrical power in a galley is largely absorbed in producing heat in deep fryers, ovens, hot plates or water heaters.
Most other equipment there will utilize small electric motors with their control switches and indicator lamps. Before any maintenance work is done on a unit, isolate the power supply at the galley section board and check the circuit for voltage with a multimeter. Prove it dead. Here, a baking oven is checked. Its heating elements are checked to earth and for insulation between each element. Now a heating element in a galley range is checked. Again, the terminals are proved dead, then they're cleaned, where there is rust, dust and grease to clear. The heating element is checked for earth fault as well as for continuity. New heating elements usually have very low insulation resistance readings until they've been heated over 360 degrees Fahrenheit. If the tests are satisfactory, check the heat-resistant insulating beads on the flexible cables. If any are damaged, replace them. Carefully feed the cables through the porcelain insulating ring and fasten the cable ends onto the terminals. Ensure that the connections are tight.
Now let's have a look at some ancillary circuitry, such as the refrigerating plant, alarms and emergency stop buttons. First, the refrigerating plant.
The refrigerating plant for the meat room, the flour room and the vegetable room is controlled via a common panel. This panel houses the relevant direct online starters which connect the appropriate motors to the supply when activated by a thermostat. In case of malfunction, check the thermostat and the solenoid valves for correct function. These sometimes get stuck in a closed or open position. Secondly, the fire and general alarms. The general and fire alarm system must be checked periodically, ensuring that the various sensors for detecting smoke or fire are functioning correctly. If a unit becomes faulty, replace it according to instructions supplied by the manufacturer.
And now, the remote emergency stop buttons.
A number of emergency stop buttons for certain engine room services are housed outside the engine room entrance, either near the chief engineer's office or the emergency control center. These are simply a set of duplicate remote stop switches. They must be tested periodically for correct function.
Now we've come to UMS operation. UMS stands for Unattended Machinery Space.
There are several alarm circuits associated with the main engine and the auxiliary machines, their lubrication and cooling systems. Their operation is dependent on a series of pressure switches, flow switches, level switches, or temperature switches, which must function correctly for the ship to remain in classification. These are usually set and tested at the periodic engine survey and should only be touched if malfunction occurs. Test the circuitry for open circuit or short circuit and replace any faulty sensor unit or switch. There are also duplicate bilge pump alarms which form part of the UMS monitoring system. These must also be checked periodically for correct function by manually overriding the switches.
Now, the ship's cathodic hull protection.
The ship's hull protection system is made up of a number of low-volt DC anode points round the ship and 2 or more reference anode points on port and starboard. The DC negative is connected to the hull. This drawing shows a typical layout of the system. Periodic checks must be made on the level of current prevailing at each station, and the data recorded for comparison and early detection of any undesired hull condition. Too low current provides inadequate protection. Too high a level sometimes results in the protective paint peeling off the metal hull. Here you see the normally sealed cofferdam for the anode points, specially opened up for our inspection. The reverse view of the anode from outside the hull looks like this. While the reference anode looks like this. Check the earthing of the main propulsion shaft, ensuring that the carbon brushes are in good condition. Check that each brush holder is earthed securely and the brushes are in good, clean contact with the tail shaft. This will ensure that the propeller is maintained at hull potential. The same purpose is served by an earthing cable to hull in the case of the rudder. Ensure that the cathodic protection system is switched off every time the hull is inspected by divers and when the ship is in dry dock.
Regulations demand that some emergency lighting and communication systems must be capable of being maintained for a minimum of 3 hours when all generated power on board fails.
A set of lead-acid or alkaline batteries is kept in a separate dry compartment with its own permanent ventilation. These batteries are kept fully charged by a battery charger during normal conditions. Periodically clean the batteries and check the condition of the electrolyte and the terminals. For lead-acid batteries, the fully charged reading on the hydrometer should be about 1.28 at 15 degrees Celsius. This will drop to about 1.11 discharged at the 10-hour rate. The specific gravity reading for the electrolyte of alkaline batteries does not change dramatically during discharge. If it drops below 1.160, the electrolyte should be renewed. Use only pure, tested, distilled water for topping up. Take care not to drop a metal object onto the battery top, as it may short out several cells, causing damage to the batteries, to the metal object, and this is most important, it could cause a fire. Full protective clothing must be worn for your safety. The terminals must be clean and tight and lightly greased with petroleum jelly. When you check the output voltage of your batteries, do not forget to disconnect the charger before you take the reading. Otherwise, you will read the charger's output voltage. A record should be kept of the date of service and any readings taken.
This concludes the subject of Programme 5 in this series. In this programme, we dealt with the ship's lighting, navigation lights, not under command lights, steering gear motor feed circuits and cabling, and we saw electric heating elements being serviced. We discussed the refrigeration equipment and dealt with a series of alarm systems. In conclusion, we dealt with the subjects of cathodic hull protection and emergency batteries. We recommend that you watch this programme again and that you consult the book Practical Marine Electrical Knowledge, which accompanies this series and will allow you to study certain aspects in greater detail. Finally, here's a list of contents for all the programmes in this series.